Kiran sir, good morning. But ముట్టిగా అనిపిస్తుందండి. Kiran sir, good morning sir.
Morning, sir.
Good morning sir.
Sir, we'll start exactly 10 o'clock, sir.
Okay sir.
Okay, sir. Thank you, sir.
My audio is clear, Nana?
Yes, sir. It is clear.
Okay sir.
Okay, sir. Thank you.
Thank you sir.
Hello, Ramchandra. Hello, Ramchandra. Hello, Ramchandra. Ramchandra, is my voice audible? Good morning, all the participants. Welcome to the day 6 and the final day of the 1 week faculty development program on artificial intelligence and its applications. Today's resource person is Dr. Kondenti P. Prasad Rao Garu. He is working as a professor and head of the department in electrical and electronics engineering at Narayana Engineering College, Autonomous Gudur. He received BTech degree in EEE from JNTU Hyderabad, MTech in Power Electronics and Power Systems from Acharya Nagarjuna University, Guntur. He had received his doctoral degree in EEE at KL deemed to be University, Guntur. He has published 24 research articles in international and national journals and presented various papers in national and international conferences. He was filed a patent to his credit. Dr. K.P. Prasad Rao Garu is a member in IEEE and life member of ISTE. His current research interests include multi-phase, that is more than three-phase systems applications in electrical vehicle related research and its control techniques. He has published 4 textbooks so far. As a resource person, he has given the outstanding contribution as keynote speaker during Global Edu Conclave 2021 held on 27th June 2021, organized by International Institute of Organized Research. Thank you so much, sir, for coming as a resource person for the day 6. Over to you, sir.
So thank you, sir. Thanks for your nice introduction about me. Good morning to all of you, dear participants. Today, 6th day of the 1 week faculty development program on artificial intelligence and its applications. In this session, I would like to explain you the 3. So in this session, we are going to discuss about the 3 things. The first one is introduction part of this program, today's agenda. And the next one is by using MATLAB, how we are going to develop the fuzzy logic and how to develop the artificial neural network for our applications. So these are the 3 agendas in this today's session. So first of all, coming to the ANN, artificial neural networks. Why we go for artificial neural networks means because nowadays we are going to solve the problems in massive parallelism based, as well as we required distributed representation and computation techniques and learning abilities, generalization ability, adaptiveness, and inherent contextual information processing, fault tolerance, low energy consumption. Based upon these requirements, we go for the artificial neural networks to compute the problems. And what are the advantages of this artificial neural network is it is having adaptive learning technique or capability, self-organization of the inputs and weights, real-time operation it will done, and fault tolerance via redundant information coding. And these are the few more applications. Previous sessions, the madam, three resource persons have explained so many artificial intelligence are and its applications in different areas. And these are the few more different areas which we are going to implement this artificial neural network or artificial intelligence concepts. So the resource persons previously explained in the view of computer knowledge point of view, like Google search, YouTube search engine, and so and so. Now, and some one of the resource person also explained it how to recognize the images also. So, but here I segregated the few more applications related to the core knowledge point of view. One is air traffic control system, animal behavior predictor or relations and population cycles, betting, criminals and synthesizing, data mining, cleaning and validation, employee hiring, and so and so. These are the different types of applications which we are going to implement artificial intelligence in core area side also. Not only the computers, as well core areas like electronics, electrical, mechanical, and civil engineering. And coming to the biological neural network. Biological neural network contains the signals are received by the processing elements. The weights are receiving and has the capability to modify. The neurons fires when sufficient input is obtained. The output procedure from one neuron may be transmitted to other neurons. The processing of information is found to be local. The weights can be modified by experience. So this is a simple artificial neural network which contains the inputs here, x1, sorry. So here the inputs are x1, x2, x3, and so on up to xn. So these are the inputs which we are going to provide to the neural network to give some output. So in between this input and output, we are going to assign the weights to the input neurons W1, W2, W3 related to the x1, x2, x3, and xn respectively. These weights we can modify, or by itself it can adjust the weights based upon the requirement. And here, as an example, I'm considering here summer as a activation function, but you can do any type, you can consider any type of activation functions also, and threshold unit. So this is some basic artificial neural network which is analogous from biological neurons, like this. So here I provided the analogous from artificial neural network basic model to the biological neuron. Cell body in the biological neuron analogous to the neurons in the artificial neural network. Dendrites, weights are interconnections. Nucleus or soma process the inputs. Axon turn the proceed inputs into outputs. And synapses the electrochemical contact between neurons. So these are the different types of elements in the biological neurons, which is analogous to the artificial neural network. And coming to the basic building blocks of artificial neural network, that is, previous slide we were seeing that only one basic structure. So based upon that basic knowledge, we are having different types of network architectures, and to processing that we require some weights that we can set, or by itself it is able to tune, and activation functions we required. So first we will see the network architecture. In this network architecture, this is a single layer feed forward network, contains one input layer and one output layer, and multi-layer feed forward network contains input layer, hidden layer, and output layer. Hidden layers may be of one or two or n number of hidden layers also it may contain. Once remember the point, once the hidden layers are increased, then the complexity of the neural network is also increases, and it takes a lot of time to compute the problem. Then fully recurrent network, one input, one neuron have the another neuron interconnections between among the neurons like this. And competitive network, another type of system, Jordan networks, and simple recurrent network. Out of the available 6 types of architectures, we are going to prefer the multi-layer feed-forward network or Jordan network in regular manner. Next, coming to the learning techniques, that is, the weight adjustment are there in the neural networks to processing the inputs to the output. That weighting adjustment by with the help of different types of learning techniques. The first one is, can you guess anybody what type of learning technique it is? You can chat your answer in the chat box. Any one of you, what type of learning technique it is? So it is a supervised learning technique. The next one is, this is supervised learning technique. The next one is, what type of learning technique it is? Any guesses? Called unsupervised learning technique. The next one is, what type of learning technique? It is reinforcement learning training or learning technique. So in the first learning technique, one of the person in front of us and teaching the class or how to modify the weights can explain, or you are going to modify the weights in your own problem. That is supervised learning. And unsupervised learning means the network itself is try adjust the weights according to your inputs as well as outputs. Then that we called as unsupervised learning technique. And reinforcement learning technique, this learning technique based upon the output data, the weights are going to be adjusted automatically, the taken output as a feedback. So that we called as reinforcement learning technique. So this is how to calculate the net input. So here x1 to xn number of neurons are there. These are the number of neurons, and corresponding weights also available. The total output, that is summation of this total input and weights, are to be calculated like this. Net input is equal to x1 into w1 plus x2 into W2 plus so on Xn plus into Wn. So like this, you can calculate the summation of the available inputs and weights. So like this, in a simple manner, we can write the total equation in the form of sum of I is equal to 1 to n xi wi. Then coming to the activation functions. So activation functions are several types. In this first one, linear activation function, nonlinear activation functions. So coming to the activation function types, in depth of the linear and nonlinear activation functions, identity function is the first one, which contains the x on x-axis and function of that is on y-axis, and the response of that one is like this. So for all x values, f of x is equal to x. Coming to the binary step function, obviously we know that the binary values are 0 and 1, and the function of that one is like this. F of x is equal to 1 if f of x greater than or equal to theta. F of x is equal to 0 if f of x is less than 0, less than theta. And binary sigmoidal function. So it is of like this, and the mathematical representation of this one is f of x is equal to 1 by 1 plus exponential of r e power minus sigma x, or you can write f dash of x is equal to sigma f of x into 1 minus f of x. And binary sigmoidal function, it is of like this, and the mathematical representation is b of x is equal to 2 f of x minus 1. So with this help of different types of activation functions, you can clearly identify in which region your input are available. In this region, or in this region, or in this region, like that, you can identify the what region it is available and what type of output you are going to get. And the last one is bias input. So if you observe in previous slides, a basic artificial neural network slide, in this one, so previously we are not discussed about the B input. So this B input is called as bias. See here, this B input is called as bias. Bias means it is a triggering point. Like as we are in childhood stage, we learn that things like A is in the form of in this shape, B is in the form of in this shape, like that. Now, if we see this, the shape of the letters like this, we can easily identify the IDEA, called as idea. So that is somewhere else in our mind, the data has stored. The data is going to be triggered as a just with of a small electrical signal in our mind, that we called as bias. So without bias, the artificial neural network not able to processing the data. So that therefore the total input value, net input value is of B plus sigma xi wi. Previously we learned up to this value what is sigma xi wi. With this one we are going to add this B also. So if you want an effective output, we need to add the bias data. So with this small introduction of regarding the today's session, I'm going to explain you the fuzzy logic development by using MATLAB toolbox, and then artificial neural networks development by using MATLAB toolbox. Is it clear to everyone, ma? Sorry. Sirs and madams, is it everyone clear? Okay, good. Now, first of all, before going to start the one, I'm going to give you some block diagram related to the fuzzy logic system, fuzzy logic have a 3 stages. The first stage is fuzzy logic have a three stages. The first stage is fuzzification. The next stage is fuzzy inference. The next third stage is defuzzification. So the first stage, how the membership functions of input fuzzy. Membership functions of input fuzzy set. The second, fuzzy inference, is called as or contains rule base. And defuzzification contains the membership functions of output fuzzy set. So normally the fuzzy logic have the number of inputs and so, but usually we consider error input and derivative of error input. In our electrical technology, we consider error is one input and the derivative of that error is another input. Then once fuzzification has completed, then we go for the rule base to create the to write the rules to compute the inputs, and then based upon the rules we are going to have the defuzzification process. Then after we are having the controlled signal. Then we are having the controlled signal called as output. So this is the process we are having in the fuzzy system. That process I am going to explain, or we are going to discuss by using the MATLAB. So first to open the MATLAB in any version. Nowadays, the latest version of the MATLAB is 2022 something, or 21B, sorry. Then here for sake of simplicity and as per my frequency with the MATLAB, I am using here a 2010B version. So first to open the MATLAB, in the command window, type fuzzy, FUZZY, and click on enter button. Now, this type of window you are having. So in this, 3 types are there. First one is input related to the fuzzification, and next one untitled white colored box, that is fuzzification inference, and blue color box called as output. And in this one we are having the defuzzification process. So if you want to increase the input layers here, previously I explained you. Hello, okay. Is it clear to everyone? Right. So you want to increase the number of inputs. First go to edit and click on the add variables. In this add variables, you are having the two types of inputs. So one is input and output. Once you click on the input, the second input is going to be add. So like this, n number of inputs you can consider because of your problem. Based upon your problem, you can consider n number of inputs. So here I'm going to explain you this fuzzy logic process with the generalized example called restaurant example. So for that I need 3 types of inputs. The first input, once you select this input, and you can change the name of that input. I'm going to change the name of the input is food test. Next, you click anywhere, the input changes to the food input 1 to the food test. The next input is food quality. Sorry, quantity. Once food taste is good means food quality also good. So that's why food quantity I'm considering here as a second input. The next input is serving time. Within a less time they're serving the food or not. They consider a moderate time, they consider long time to serve the food, like that. And output is, at finally we are going to provide the tip to the bearer, so that's why tip money. So with this type of input and output modifications, double click on any one of the input or output, you are having the another dialog box like this. So in this, the first one, food test. Normally we are having a three types of membership functions, three membership functions, like membership function 1, membership function 2, membership function 3. I'm going to change these membership functions with their names also, types of membership functions and their names. First of all, before going to change the types of membership functions and assign the values, you need to consider the range of the display. So by default it is 0 to 1, but I'm going to consider 0 to 4. Once you click anywhere on this, the display range changes instead of 0 1 to 0 2 to 4. Then select membership function and rename that one. So this input related to the food test here, which I was which is the highlighted with red color border line. So food test means three types of tests I'm going to consider here. One is food test is good, and the membership function shape, here we are having triangular membership function, trapezoidal membership function, Gaussian bell membership function, Gaussian membership function, and sigmoidal, and so and so. So here I'm considering the trapezoidal membership function, and trapezoidal membership function have the shape is of like this. The trapezoidal membership function shape is of like this. This is 1 point and 2nd point, 3rd point, and 4th point. Triangular membership function contains like this. So 3 points it is having, 1, 2, and 3 to represent that membership function. Gaussian bell membership function is of like this. It will be like this. Gaussian membership function is of like this. So like that, different types of S membership function is there. The shape of S membership function is of like this. Z membership function is also available. It is of like this. So different types of membership functions are available. You can consider as per your wish any type of membership function, but there is having some significance in each and every membership function. So here I am considering the trapezoidal membership function as an example. The first one starts from -1, 0, 1, and 2. 4 points are given with respect to the x-axis. So once you assign the values, click anywhere on the window. See the membership function shape changed from triangular to the trapezoidal. Before this 0, -1 is there. It is not visible because we assign the range 0 to 4 only. Or if you want, for sake of understanding, I'm going to change the membership function values from 0, 1, 2, 3 and click enter. See here, this is your trapezoidal membership function, right? So instead of like this, I'm considering like this. So the reason to consider like this, the first membership function, whatever the input we are assigning to this one, those all the inputs are need to consider by the fuzzy logic. That is the reason I'm considering the triangular membership function as a first membership function. Sorry, trapezoidal membership function as a first membership function. Second membership function, food taste is average. Food taste is average, and it will be a triangular membership function. And I'm going to change the values as 1, 2, 3. This is your second membership function, average. And third membership function, food taste is bad. And I'm considering this one as trapezoidal membership function and changing the values like 2, 3, 4, 5, like this. See, the first membership function related to the food taste is good. The second membership function, food taste is average. The third membership function, food taste is bad. Similarly, coming to the second input, food quality. Consider the first one. Food quality is heavy. Sorry, food quantity is heavy. Trapezoidal membership function, and the same values I'm going to assign to this one also. Minus 1, 0, 1, 2. Sorry, I forget to change the range 0 to 4. First range you need to change, then change the membership functions values. 1, 0, 1, 2, like this. And second membership function, food quantity is average. Average quantity served by the restaurant. And 1, 2, 3. And third membership function, food quantity is very less or less. Trapezoidal membership function, the membership function values 2, 3, 4, and 5. This is the second input assignment. Next, serving time. Serving time, first membership function, sorry, change the range 0 to 4. First membership function, serving time is less. That is very quick. They serve the food within a less time. Or you can write for your sake of understanding, less time. Trapezoidal membership function minus 1, 0, 1, 2. And second membership function, serving time is moderate. Triangular membership function 1, 2, 3. The third membership function, serving time is more time to serve the food. Trapezoidal membership function 2, 3, 4, 5. So like this, assigning the membership functions with some relevant values to the inputs, and similarly to the output also. Tip money. So normally as a human being, we thought that food taste is very good and serving time is less time and quantity is also more. We generally thought that the tip money need to provide the server in huge amount. So like that, if it is a moderate tip money, we can provide to the server, or all the quantities like food taste, food quantity, serving time, is everything is bad. We are not preferring to give tip money to the server. So like that, the output tip money is high. The first input, first membership function, and consider the trapezoidal membership function minus 1, 0, 1, 2. And second membership function called moderate money. One, two, three. And third membership function, less tip. Trapezoidal 2, 3, 4, and 5. So once after assigning the membership functions for the different types of inputs and output, close this window. Background it has stored, just close the window, then go for the basic one. So here food test. If you have any doubt, please check it once by clicking any one of the input and output. You can see everything. So see food taste, food quantity, serving time, tip money, everything is whatever we assigned, the values are available. Next, here we need to concentrate a few more things. First one is AND method. So the rule you can write based upon the AND base or OR base. AND base or OR base, you can assign the rules. So we know that what is AND gate truth table? What is AND gate truth table? So AND gate truth table is if both inputs are high, then your output is also high. Our R table may R gate truth table is if any one of the input is high, the output is high. So like that, AND method you can use or R method you can use. So here AND method we are having a minimum or probable time and custom also. So I'm considering here minimum time as default and R method also maximum as default. And coming to the defuzzification process, we are having centroid here and bisector, mom, lom, and sum. And customized also is there. Centroid means whatever the membership function you are assigning to the input or output, it will calculate the total area and give the center point to give the output value. Bisector means it will take two parts. So which part is optimistic to our output, that will give by the fuzzy system. Mom means maximum of middle of maximum. So in the membership function, which value is in middle, that value is going to be provided. And LOM means largest of maximum. It will give you the largest value in the maximum membership function. And SOM means smallest of maximum. Right, in the membership function, which is the smallest value, it will give you the one. So out of all the techniques, centroid is best one and optimistic one to to compute the problem called previously we discussed it in the PPT, through the PPT called activation functions. So those activation functions here in the defuzzification process is centroid is somewhat optimistic and nearer to our problem solving. So that's why I consider the centroid here. Then double click on the untitled box, which is a white colored box. In this, once you observed, one name is there called Mamdani. So not only this Mamdani, we are having one more algorithm called Sugino. Sugino is another one. So by default here, the MATLAB provided the Mamdani algorithm because it is well suited to human inputs and more interpretable rule base also. That's why they provide Mamdani as a default algorithm here. If you want to change the Mamdani to Sugino, you can change. Somebody based upon their problem analysis and based upon their interest, Sugino they can use, because Sugino is a computationally efficient algorithm. That's why they can use the Sugino method also. But as a basic part, we are going to use the Mamdani here. So double click on this white box. You are having this dialog box once again. So in this, see, food taste is good, average, bad. Food quantity is heavy, average, less. Serving time is less time, moderate time, and more time. And tip money is high, tip money is moderate, tip money is less. So based upon this three inputs and one output, how many rules we can able to write? Can you guess? How many rules we can write? Based upon these three inputs and one output, how many rules you can write? This is one more important point in this fuzzy logic rule base. Until unless you are not having the idea, you can go for any type of research paper and consider the rule table or rule matrix from that. So if it is providing you the optimistic value or optimistic results to your research, you can use that one. Or otherwise, you are having a exact clear-cut idea about your problem, you go for here like this. So here in the first input, 3 membership functions are there. In the second input, 3 membership functions. So once you write the matrix, it is 3 by 3 matrix. How many inputs? Totally 9 rules we are having. So those 9 rules and combined with 3 another input membership functions, we are having total 27 rules we can able to write. So see once again here how we can able to write the one. So first, food taste is good and food quantity is heavy. Serving time is less time. If this type of inputs, what is your tip money? I myself, I'm very satisfied about this type of inputs. That's why I'm going to provide high tip money. So once you select all this, click on add rule. So in this white box, see here, if food taste is good and food quantity is heavy and serving time is less time, then tip money is high. This is one rule using the AND method. Or if you want to use OR method, see OR and add the rule. If food taste is good, OR. If it is not, go for this one. Food quantity is high, OR. If it is not this one, go for this one. Serving time is less, then tip money is high. So if any one of the input is high, then the output is also high. Whereas in the AND case, all the inputs are high, the output is high, or otherwise it is low. So if you want, I want to make the rules with the help of AND rule. So that's why I'm going to delete this OR rule. Select that rule, whatever the rule you want to delete, select that one and click on delete rule. It will delete. Next condition, food taste is good, food quantity is heavy, and serving time is moderate. Even though I'm going to provide high tip to the server, add rule. And food taste is good, food quantity is heavy, more time to take serving, and I'm going to think about tip money is moderate, add rule. And coming to the next cycle process, food taste is good, food quantity is average, serving time is less time. Again, I'm going to give a high tip to the server, add rule. Food taste is good, food quantity is average, serving time is moderate, then I'm going to provide the tip money is moderate. Food taste is good, food quantity average, serving time more time, then I'm going to provide less tip money to the server. And next case, next set of rules, food taste is good, food quantity is less, and serving time is less time. Then I'm going to think about the moderate tip money. Next, food taste is sorry. Food taste is good, food quantity less time. Okay, moderate. Clear. Next, food taste is good, food quantity is less, food serving time moderate, then tip money is moderate. Food taste is good, food quantity is less, serving time taking a more time, and less tip money I'm going to provide the server to the server. So like this, the next set of inputs with related to the food test average. So like this, you can write n number of 27 number of rules based upon the your requirement. So here I'm explaining first set, and remaining sets I'm going to provide like this. Don't think about myself or sir is not explaining the things and like that. And come to the bad, heavy, less time, moderate, tip, bad, average, sorry, heavy, moderate. Sorry, here I made one mistake. Average, heavy, heavy, average. Then food taste is less. So more, less time, heavy. So average, less time to take, less tip money, less moderate, less tip money, less more time, less tip money. And bad, coming to the bad food taste, even though it is heavy quantity and less time it takes to serve, I'm going to provide average tip money, and moderate means less tip money, and taking more time is obviously less tip money. Coming to the average and less time, moderate tip money, I'm going to provide average and moderate time, going to provide moderate tip money, and with less time, less I'm going, more time, I'm going to provide less tip money. Less quantity, even though serving time is less, going to provide less money, and moderate also less tip money, and more time to take serve and less tip money. So totally 27 rules we are having based upon the 3 inputs and 1 output. Any doubts up to Ma? It is clear how to develop or how to write the rules. Then close this window. Automatically it is having, or if you want to check, you can check. Double click on this. Total 27 rules are available in the rule box. Now go to the view option, click on the rule, or in a shortcut manner, Control 5. Click on this rule box, rule menu, submenu. You are having this rule window, rule viewer window. So this is the line to select the type of rule in the first one, that is food taste and food quantity, range of the input, and serving time and tip money, like this. So here the red line, with left mouse click, click on it and change the position of this red line. So here I'm changing the position of the red line to the food taste is good. See, these are all the inputs related to the good only. First 3 good in this one, first 3 good in this one, and good, average, less time. So like that I'm having the inputs. So if you change this second input from here to anywhere in your input rule, so like this, see, all our food quantity is heavy, options are highlighted, and serving time is the more time in each and every case are highlighted. Then your tip money is more. See, given the value is 0.767. So this is 0 value in your rule table. We consider 0 to 4 na. So that this is a 4 and this is 0. So in between this, any value you can compute. See, normally we consider 0 and 1 as a binary value, but this fuzzy logic contains the continuous evaluation also. So that's why any value you can place the red line 0 to 1 to 3, in between that they will provide some value, and food quantities of like this much value, and serving time 0.428. Your tip money is of 0.767. That is, food taste is 48% out of 100%. Food quantity is 72% out of 100%. Serving time is 42% out of 100%. Your tip money is 76% out of 100%. You can provide to the server. So again, change your rule line, moderate, somewhat related to the good and somewhat related to the average food taste, and food quality is in a good manner, and serving time is in less time. See here, your tip money is of 85% out of 100%. Both are in high tip money stage. Or if you can change this one like this, the relevant answer you can have. And like this, you can have the relevant answer. And you can change this one, you can have the relevant answers. So like this, you are going to check your assigned inputs based upon your problem. It will provide you the more value or not, or sorry, correct value or not. So this type of analysis we are going to explain the students in case of electrical engineering point of view, to provide a fuzzy logic control system instead of PI control system, to control the generator speed, or to control the motor speed, or to control the voltage, power factor and frequency in the power systems. They are going to provide this type of fuzzy logic system and implement into that. Not only electrical engineer, nowadays we are having all the houses fully controlled washing machine. So fuzzy controlled based or fuzzy logic based fully controlled washing machines provided by the company called Lloyd, right? So there also they are providing, they are analyzing the system based upon this type of inputs. For example, let us see, you are providing the bed sheets to wash by using the washing machine. So that is heavy weighted clothes. So for that, what you required, heavy weighted surf, heavy surf you required to wash this heavy weighted clothes, and you are going to provide the huge water to wash that type of clothes. Then it requires lot of time. So like this, like this, you can analyze this system based upon your application and based upon your implement of this fuzzy logic in your projects. Then after identifying the rules and their evaluations as per your required output, simply click on the close button. Then it will ask you the, you want to save this system or not. Yes, I want to this system to implement somewhere else in our project, in my project, or in our projects. So I simply click on yes. Now I'm going to save this total system with the name of restaurant example RE, and the extension of this file is .fis. Save this one. Now here, as a computer science engineering faculty or any other faculty need to have this system in your programming point of view, open the MATLAB M file, which is called programming file it is. So open that your already assigned fuzzy system file into this by selecting all files like this. So this is your program behind the toolbox based fuzzy system. So you can use this program anywhere in your problem while you are doing with the help of programming. You can use this one without small modifications based upon your language, C language, MATLAB or Python, anything. So like this, you can analyze the fuzzy system based upon your research and based upon your application. This is one type of AI technique to implement our brain thinking knowledge in artificially. Next one, we go for ANN. So for that ANN toolbox, simply click here NN tool. NN tool in the command window of MATLAB. Click on it. Sorry, press the enter button. You are having this type of window. Sorry. Right. You are having this type of window. So in this, we are having input data, target data, input delay state, networks, output data, error data, and so options. So first we need to assign our input to this data. So for that, what we are going to do is, so before assigning the input to the ANN artificial neural network, all of you keep it in your mind one point. Artificial neural network is well performed with of n number of inputs. With a few number of inputs, it can perform, but the results may not be suitable to your required output. That's why the neural network will able to train perfectly with the help of n number of inputs. So that n number of inputs are going to assign like this. First, in the workspace of the MATLAB, see here, this is import data and new variable. So by using these two types of inputs, you can assign the data to the workspace. Then from the workspace, you are going to call the data into the neural network. So first, I'm going to create one new variable. See here in the workspace, there is no data right now. Once I click this new variable, it is providing one unnamed file. That unnamed file I'm going to change like input data. Input data. Then I need to consider one more file or one more variable. That variable is going to be renamed with output data. Output data. Now, once you click on this, double click on this, your MATLAB window shows you this type of Excel sheet. You are assigning the input data by typing directly here 0 by using the arrow marks or mouse click 1, 2, 3 like this. You can assign the values, or it is somewhat difficult if you feel, then you go for the any Excel sheet. Any Excel sheet, assign the values, whatever the values you required as per your research or as per your problem. Like 0, 1, 2, and so. Once you select this and drag the data, it will drag up to like this. So it is somewhat simple rather than the typing the data in the workspace sheet directly in the MATLAB. Again like this. Sorry. Now, this is nothing but this data I'm going to consider as input data. I'm going to consider as input data this one, these two lines. Okay. And the third row, consider as output data like this. So sorry, sum of the inputs. Auto sum you can consider, or you can write a formula like this also. So drag this one, the formula applicable to each and everything. Output data. So once you are taking the values in the Excel sheet, you simply copy paste of these values in MATLAB. Copy these values and go to MATLAB workspace window and select this one box, paste it in this one. See, the values are assigned in this one, and see here the values in the command workspace 2 into 18. So 2 rows is there with of 18 values. 1 to 17 and 0 is the another value. Total 18 values it contains. Now click on the output data. Copy this one and paste into this. So one row with of 18 elements. The output data contains one row with of 18 elements. Input data contains 2 rows with of 18 elements. So once you assign this input data and output data to the MATLAB workspace stores this data temporarily. Once you close this MATLAB, this data may not be available in future. So this is going to be provided whenever you are opening the MATLAB, or otherwise once you completed your development of the tool NN by using NN toolbox, that toolbox you can that tool you can use anywhere at any time wherever you required in your project. So go to this one. Here import option is there. Click on this import option and select import from MATLAB workspace, or you can load the data from the disk file. So whatever the Excel file I am loading on my desktop, that you can select from by this option. So because of this, it is somewhat easier to assign the values to the artificial neural network. So that's why import from MATLAB workspace, select input data, and destination is also input data. Then click on import. Then click on OK. So close this one. See, under the input data, you are having the input data here. Whatever the data you are having in the workspace, that data called to here. Then under the target data, click on the import from MATLAB workspace, output data, select output data and select destination also, that is target data, and click on import. Click on OK. Close this one. So here under the target data, you are having the output data. So with this input data and target data, you are having the you are assigned the data to the neural network to train the network. So then next go and click on the new. After the import button, new button is there. Click on this. You're having this window. What type of example we are doing now? What type of example we are doing now? Add of the two numbers. So that's why I am providing the type of network name is adding. Then after the network type, there are so many network types are there. So in the PPT, we were observed that 6 types of networks: single layer network, multi-layer network, feed forward network, like that. Different types of networks we were seeing. So out of those all the networks, I mean, out of the availability networks here, cascaded forward back propagation network is there, competitive network is there, feed forward back propagation network, feed forward distributed time delay network, and so are there, right? So go, I'm here, I'm choosing feed forward back propagation network. Then after it asks the data, what is input data? Select an input. From input data, whatever you are going to have in the input data, under this input data, that input data you are selecting here. Next, target data, select the output data. And training function. See, in previous example, in fuzzy logic, we are having a trapezoidal, triangular membership function, sigmoidal membership functions. Like that, different types of membership functions are there. Here also, Gaussian membership function, Gaussian Bell membership function, like that. So out of all the available membership functions, triangular membership function I have chosen. Then, coming to the number of neurons available in hidden layer, either 5 or 10 or 2 or 9, 100, whatever it may be. Okay. So then, and remember one thing, the hidden layer, number of hidden layers increases, the complexity of the artificial neural network also increases, and it takes a lot of time to compute the problem. So that's why optimistic hidden layer neurons going to be considered. Okay. Then after selecting all the information, whatever you required, click on the view button. With this data, it provides you the artificial neural network connection diagram. See, this is input layer, contains the two inputs. We are assigning two rows with of 18 data, 18 elements now. So two rows, each row contains one input and second row contains the another input. So that's why two inputs are here. In the hidden layer, 10 neurons are there. In output layer, one neuron is there. So that is one neuron means we are having the one row as an output data in the Excel sheet. So that's why it provides you the one number here. If you want to change the hidden layers, instead of 5, sorry, instead of 10, 5, you can change the 5 and click on view button again. It shows you the 5. Instead of 10 neurons, it considers only the 5 neurons. Or if you want to change more number of neurons, instead of 10, 20 neurons you required in the hidden layer, it considers the 20 neurons here. But input and output layer neurons, it purely depends upon your input data and output data, which were provided by you. Okay. So like this, after creating the required, after creating the artificial neural network, close this one, close this one, sorry, 1 second. Okay. Then click on create button. After view the your whatever the whatever the feed forward back propagation network you are assigning, after once you identify the it is good to our project, then click on create button, then click on OK, then close it. So now here under the networks you are having the adding network. So this is your neural network now. Now we are going to select this one, open that. Now go and click on the train button. Again, once again, you are going to provide the input data and target data, then train the network. Once you click on this train network, based upon the inputs and output data, based upon the input and your required target data, that is output data, it takes 6 iterations to train the network. It takes 6 iterations to train the network, and time to train the network is 2 seconds. And then go for the regression analysis. Click on this regression analysis. You are having this type of graph. So this graph represents the your network is well trained or not. Your network got the trained in very well manner or not, it is shown to you. So that is, this dotted line is coincidence with this blue line, and this dotted line coincidence with green line, this dotted line coincidence with red line and black line. Then your regression, both lines are matched, then your network is well trained, or otherwise not trained. So that's why if it is now at this stage, it is not well trained. Now I'm closing this window. Click on the closing this window also. Click on once again the train network. So by this time it takes only 1 iteration and less than 0 seconds it takes, and click on the regression to see the system is well trained or not. See, all are beyond the graph. So once again close this one, again train the network, go for the regression. So check like this once or twice or thrice, the network is trained properly or not. So again, the same way it is training. There is no iterations to train the system, and there is no time to train the system. So your system will not train beyond this limit. That is the meaning of this type of regression analysis. Then click on the simulate, click on the adapt, click on the rationalize weights. So here you can adjust your weights. 2 inputs are there. One input have 0 weight, another input have 17 weight, like that. So 0 to 17. So this system does not trained well. So for that, I'm going to consider another system with of same examples. Once again click NN tool, import the data from the workspace to the input data, and output data to the target data, and close this and click on the new. Adding is the name of my ANN, and instead of feed forward back propagation network, here I'm going to consider radial bias basis exact fit. So in this, after selecting this, select the input data and output data. View on this similar type of network it's shown with of 18 hidden layers. Okay, 18 entities are there in the input data and output data. That's why 18 layers it is considered. Previously we are considering only 10 10 layers, 10 neurons in the hidden layer. That's why maybe it is not properly trained, because input data is huge, but number of neurons considered in the hidden layer is less than the input data. That's why it may not be trained well. Then create this one, click on OK, close it, close it. Then click on adding, open the one, train the data. So it does not consider any data because we are considering the exact fit radial base model. That's why it does not require any training process. Now export, select, after selecting the adding network, click on export and select adding, click on export. Now here, other than the input and output data, there is no another file. Once again, once you click on this export data, see here, the MATLAB workspace contains the adding network. Click on OK and close in this. So after all this done happened by you, simple, give a command called gen sim of adding. Gen sim of adding. Click on enter. It takes some time to generate this Symlink box. So this is your Symlink model, and this contains the artificial neural network. Once you right click on this and go click on edit mask, you can identify the, sorry, look under the mask, sorry. You can identify the neural network as layer 1. This is which contains the input, weight adjustment and bias input, net product, star mark here, and radial bias contains as activation function. And in the second layer, weight adjustment, bias input is there, and net sum. Previously net product, and here it is net sum, and pure linear model as an activation function it is having. So different types of activation functions and different types of products and summation, addition, subtraction, like that, it is contains. That we called as a processing system. This we called as processing type, and this is activation type. So like this, in 2 layers, you can observe your neural network with of what type of processing processing element it is contains, and what type of what is that activation function it contains. Then after that, click on this X1 input data. So we are having a 2 inputs. Then it shows you the 2 inputs here. Wait for some time. Right. So this is one input up to here, before the colon, after the colon, and before the colon it is another input. So 2 inputs we are assigning to the neural network. So out of those 2 inputs, first I am going to select 0 as one input and 0 as the second input. The output is sum of this one. To see that one, remove this. By default it is a scope window. Remove this window, remove that block, and take the display block from Symlink library. From Symlink library, take the display block. sorry, like this. And once you assign this all the things, click on the run button or play button which is available. See, the output is 0. See, the output is 0 here. After providing the 0 input and 0 is one input and 0 is another input, you are having the 0 output. Or else providing the another data called 6 and 6. Run this one. It shows you the 12. Or you change the input data 6 and 4. One input is 6, another input is 4. Run the one, it gives you the 25. That is 6 4s are 24. Now it takes product. Whenever you're providing the two input data values are same inputs, it perform the AND operation, adding operation. Whenever you provide the two different types of inputs, 8 and 2, it give you the answer like this, product and like that. It's a different answers because we train the system for the adding function. We are not trying the system for other than the adding function. That's why it shows you the different values. Okay, 10 and 10. Click on this. So like this, and now this block, remove this one and remove this one. Now this block alone you can use anywhere in your projects, anywhere in your hardware kits, hardware experiments or hardware experiment implementation through MATLAB. You can use this block alone to control the output based upon your inputs. So like this, you can able to perform the artificial neural network by using the artificial neural network to apply the any applications, based upon your experience and based upon your project requirement, like that. So this is what today's agenda. The first one is basic information related to the ANN and fuzzy logic. Then fuzzy logic, by using fuzzy logic toolbox in the MATLAB, how to develop the fuzzy logic to compute the problem. And then artificial neural network development by using the artificial neural network toolbox in the MATLAB to compute the problem. These are the three outcomes which I was explained in the beginning of the session. These are the three outcomes. So with this, my presentation completed. If you have any queries, you can ask me. I will try to clarify your doubts.
Sir, thank you so much for your explanation.
Thank you, sir.
It was quite wonderful.
Thank you.
So participants, if you have any doubts, you can type in the chat box or you can directly raise your hand so that I can unmute you and you can ask your questions. Feedback form will be posted in the next 2 minutes. Please wait. So meanwhile, if you have any questions, you can please ask your questions. Sir, no more. One question is there, sir. 1 minute. Neha Gupta, you can ask your question.
Yes, sir. Thank you, sir. So first of all, I would like to thank Gus for having such a wonderful presentation. and informative also. Sir, I would like to ask that whether it will be applicable for the images or videos also on MATLAB?
Sir, one of that, sir, can we use MATLAB for image as input? Yes, ma'am.
On the videos, sir, as on Python, I guess it is more complicated because here we are getting a much more easier way to access through MATLAB.
Yes, it is very easy to identify the pictures. Yesterday, madam told that image processing like that.
No, sir, if we want to apply on videos also,
Okay,
the deep learning models,
right, you can.
we can?
Yes, you can, ma'am. No problem.
Okay. Thank you, sir.
No more questions.
Sir.
Thank you for your session, sir.
Okay, sir. Thank you.
So thank you all the participants. Before posting the feedback for the final day, I thank all the participants as well as the resource person for day 1, 2, 3, Mrs. K.M. Annamal, ME PhD, Assistant Professor CSC, Grace College of Engineering, Tamil Nadu. And on day 4, Ms. Suhashni S., ME, Assistant Professor, Department of Computer Science and Engineering, RMD Engineering College. And on day 5, Mrs. R. Satya, Assistant Professor, CSC Department, SRM Institute of Science and Technology, Ramapuram Campus, Chennai. And the final day and 6th day, Dr. K.P. Prasad Rao Garu, Professor and Head of the Department of EEE, Narayana Engineering College, Gudur, for coming as resource persons for this FTP and making it a grand success. And finally, I thank all the participants who have participated for all the 6 days. Regarding the e-certificate, those who have given at least 5 days feedback would be given the certificate on Tuesday. You will receive the certificate in your email on Tuesday. Okay. So those who have not given the feedback for 5 days will not be qualified for the certificate. Thank you so much. And the feedback form is now posted in the chat box of the Zoom as well as in the YouTube. You can fill the feedback form now. Thank you. Thank you, sir.
So thank you very much, sir. Thanks for your nice presence here.
Thank you, sir.
And I would like to meet you once again in some another platform like this. Thank you very much. Thank you all.
Sure, sir. Thank you, sir. Thank you so much.
Thank you.
All the participants who have given the feedback form can leave now. Thank you so much. The next events details are already there in the Telegram group, as well as you can visit the website csctechwings.in and you can register over there. Thank you so much for attending the FDP. Those who have given at least 5 days feedback will be given the certificate on Tuesday. Thank you. All of you, please fill the feedback form before leaving, and those who have filled the feedback form can leave now. Thank you. Bye.
Sir, one of the participants asked me that is MATLAB is a free version or not? Free version is available as well. Free version means cracked version is available as well. Online version also available, because it takes a lot of money to buy, more than 2.5 lakh like that. So you can use your Gmail ID or a Gmail account, create the account in the MathWorks. You can use through online also.
Okay, sir. Thank you, sir. All of you, please fill the feedback form before leaving. Those who have filled the feedback form for 5 days will receive the certificate. Less than 5 days, a certificate will not be considered at any cost. Thank you so much.
Sir, can I leave now, sir?
Sir, yes, sir. Thank you, sir. Yes, sir.
So thank you very much, sir, once again for
Thank you, sir.
providing this platform to me. Thank you very much.
Thank you, sir. Thank you, sir.